Good morning, children. Today we will do the revision of the chapter Machines. As you all know, machine is a mechanical device which makes work simpler and easier. But technically, this is not what we write or we will be writing in the exam for or as uses of machines or functions of machines. There are many functions of machines. But before we go further into this topic, we will first of all do the revision of some important technical terms related to the topic. And the first one being the definition of effort. Whenever we apply force on a machine to do a certain task, that force is known as effort. Next term is load. Now, machine in response to the effort applied, it also applies some force, and that force is known as load. The distance through which the force that we apply moves is known as the displacement due to effort, and the distance moved by the machine due to load is known as displacement due to load. So these are the few technical terms, but whenever you apply some effort and because of that force or effort applied there is a displacement, then there will be work done. Similarly, the machine which is also applying some force, when we apply effort on that machine, now due to this force again some displacement is taking place, that means machine will also do some work. So the next two technical terms that we will discuss or do the revision of is work input and work output. Let's see what is work input. As I've said just now, that work input is due to the effort that we apply, and because of this effort there is some displacement taking place. So work, as per the formula of work, it is force into displacement. So work input will be given by E into dE, where E is the effort applied and D is the displacement due to effort. Similarly, work output will be given as L into dL, where L is the load and dL is the displacement due to load. Then comes the next important term, and that is efficiency of a machine. Efficiency of a machine is denoted by the symbol eta, and it is given by the formula work output upon work input. So when we will put the values of work output and work input into the expression, we will get so, as you can see in this expression, it can be written as L upon E multiplied by dL upon dE. Now, if you look at the formula for efficiency, which is work output upon work input, how can we define this? Basically, efficiency is the percentage of work put into a machine by the effort that becomes work done by the machine. So, what happens basically, this work output is always equal to work input only if the machine is ideal. That means there are no losses taking place. But practically or in actual machines, work output is always less than work input. Now, when we have splitted the expression and we have written, as you can see here, that this is L upon E multiplied by dl upon dE, we can further deduce some very important relationship between the efficiency and two more terms. And those two terms are mechanical advantage and velocity ratio. I have rewritten the expression for eta. So, L upon E is nothing but the mechanical advantage of a machine. So, MA, and dL upon dE is 1 upon VR. And therefore, the expression for eta in terms of MA and VR becomes MA upon VR. Efficiency is generally found in percentage. So, if you want to find the percentage efficiency, you can always multiply this ratio by 100. So, in an ideal machine, the efficiency is always 100%. Why? Because the input work is always equal to output work, and therefore, the mechanical advantage is always equal to velocity ratio. But in actual machine or in practical machines, the efficiency is less than 100%. Why? Because there are some losses that happen due to friction, due to moving parts of the machine, due to wear and tear of the machine. So, the input is more than the output work. These losses reduce the mechanical advantage, and therefore, mechanical advantage becomes less than the velocity ratio, and this decreases the overall efficiency of a machine. The efficiency is a ratio of two like terms. Therefore, it is a unitless quantity. So, ideally, when we are saying that the efficiency of machine is 100%, so if we do not find the percentage efficiency, then we can write ideally the value of efficiency should be 1, and in a practical machine the efficiency value should be less than 1 when we are not finding out the percentage efficiency. So, that was all about the scientific term efficiency. Next, we will move on to the discussion of MA and VR. These two quantities, especially MA, is a very important scientific term to understand how a machine works and in what way we can use a particular machine. So, mechanical advantage of a machine is equal to load upon effort. Again, it is the ratio of two like terms, therefore, it is a unitless quantity. Mechanical advantage of a machine is important because it tells us how much force a machine exerts when a certain amount of force is applied. That means it tells us how much load is, how much effort is needed to do a certain task, and the machine whether it will give us higher efficiency, lower efficiency, or it will be used as a force multiplier or a speed multiplier. For example, if I have a machine with mechanical advantage 10 and the load which is to be lifted is of mass 100 kg. So, that means the load, value of load will be 100 into 9.8, which is 980 Newton. This much load we have to lift by using a machine whose mechanical advantage is 10. So, that means the effort which I will apply as per the formula given above will be equal to load upon mechanical advantage, which is 980 upon 10, 98 Newton. Hence, if we are using a machine with mechanical advantage 10 and we have to lift a load of 980 Newton, the effort that we will apply will only be 98 Newtons, which is 10 times lesser than the load, and that is the significance of mechanical advantage. So, basically mechanical advantage tells us whether the machine can be used as a force multiplier or not. So, mechanical advantage, if the value of mechanical advantage of a machine is greater than 1, then that particular machine is used as force multiplier, and if its mechanical advantage is less than 1, then definitely it will never be used as a force multiplier, but it is used as a speed multiplier. I hope you must have understood the importance of mechanical advantage with the help of this example. One more important point to be noted is that a machine with greater mechanical advantage if you have a machine with greater mechanical advantage, the lesser the effort you need to apply to do a particular task. So, basically we always prefer a machine with greater MA, so that we apply minimum amount of effort to do a particular task. So, that is the significance of mechanical advantage. I would like to explain you this concept further with the help of a machine called plier. Now, one more thing to be noted, that the mechanical advantage of a machine which is considered as a force multiplier comes at the cost of speed. This you must remember, because this will help you to understand the working of plier in the example. So, you can now see a picture of a pair of pliers. Now, when you press the handles together, the two handles of the plier together, it causes the other end of the handles to compress the object. As I have told just now, that if a machine is used as a force multiplier, that comes at the cost of speed. So, the distance moved by the end of the plier where we are holding the handle is more than the other end. Hence, we can say that the distance moved by the end where you have put the object is shorter, but with greater force. So, this is a force multiplier. That means it has come at the cost of speed. That means in a force multiplier, the effort is applied over long distance and the load is moved by a short distance. And this machine will have always mechanical advantage greater than 1 as well as velocity ratio greater than 1. Now, here comes the concept of velocity ratio, which is the ratio of displacement due to effort to the displacement due to load. So, here definitely in the figure you must have observed that the displacement due to effort is more than the displacement due to load, and therefore, the ratio is greater than 1. There is one more picture where you can see a machine that increases the distance over which the force is applied, and technically you call this distance as load arm. The effort is applied at the end of the handle and it is moved to a short distance. Now, this concept is just the reverse of the concept of the plier that is being told to you just now. However, the other end of this machine moves over a greater distance, but with a lesser force. So, here this machine does more work than one can do with their hands alone, and this machine is considered as a speed multiplier, because here the load moves greater distance than the effort, and therefore, the amount of load that means the value of load is more than the effort. So, the machine has mechanical advantage less than 1 and hence velocity ratio is also less than 1, and it is considered as a speed multiplier. So, basically a force multiplier is a machine whose mechanical advantage and velocity ratio both are greater than 1. We will focus mainly on the mechanical advantage term, because this term only tells us that whether the machine is a force multiplier or a speed multiplier. So, in a machine which is being used as a speed multiplier, the mechanical advantage will always be less than 1. So, that is the conclusion, that a force multiplier will have mechanical advantage always greater than 1, and the greater the value of mechanical advantage, the better is the force multiplier as a machine as a force multiplier, and the velocity ratio will also be greater than 1. For speed multiplier, mechanical advantage is less than 1 and velocity ratio is also less than 1. Velocity ratio, which is the ratio of displacement due to effort to the displacement due to load. However, the actual according to the definition of velocity ratio, it is the ratio of velocity due to effort upon velocity due to load. But when we will reduce it in terms of distance and time, we will get this ratio. Now, velocity ratio of a machine remains constant for a particular design. You change the design, then only the velocity ratio will change. However, mechanical advantage of a machine, as told to you earlier, that mechanical advantage and efficiency of a machine change because of losses that take place, but velocity ratio will always remain constant. So, these were few technical terms which were required to be discussed before we understand the functions of machine, functions and uses of machine. So, next is the functions of machine. Basically, there are 4 major functions of machines, and since here we are talking about only simple machines, so we will mainly focus on those functions. Let us see one by one. So, scientifically, machine performs 4 functions. The first one being is that it is used to overcome large resistive force. For example, if you use a jack, to lift car, heavy, which is definitely heavy, spade, pulleys. Now, here the pulleys which I am talking about is not the single fixed pulley, but it is the block and tackle system of pulleys where the mechanical advantage is more than 1. So, that means when you use a machine to overcome large resistive force, basically you are using a force multiplier whose mechanical advantage is greater than 1. So, this is the first function of the machine. Let us see what is the second function. This is the second function of a machine, and this is to obtain the gain in speed, and these machines are also called speed multipliers. One important thing to be noted, that in these types of machines a greater movement of load is observed. That means the value of DL I am talking about right now is as compared to the movement of the effort, that means DE. That means here the distance or the displacement due to load is greater than the displacement due to effort, and the example is that of a bicycle. A bicycle provides gain in speed. Similarly, a scissor has a longer blade so that the load moves a longer distance than the effort. Another example is that of a knife. It also has a longer blade than its handle. So, its blade moves longer by giving smaller distance to its handle. And in all these examples, what we observe gain in speed, and these machines are speed multipliers. So, in general, in a speed multiplier, the blades are longer than the handles. Therefore, the value of displacement due to load is greater than the displacement due to effort, which reduces the mechanical advantage and it becomes less than 1, and also velocity ratio is also less than 1. On the other hand, if a machine is a force multiplier, then the reverse is the condition. In a force multiplier, the displacement due to effort is more than displacement due to load, which increases the value of mechanical advantage, and its value becomes more than 1, and hence for velocity ratio also its value becomes more than 1. And in all the machines which are used as a force multiplier, you will find their handles are longer than their blades. So, this is the second use of machine or the second function of a machine. Let us now move on to the third function. So, apart from these two functions which we did just now, a machine is also used to change the point of application of the force or the effort to a convenient point. For example, if there is a screw fixed in some body, then you cannot pull out the screw directly. You need a screwdriver and you will apply force at its handle. Similarly, the wheel of a cycle is rotated with the help of a chain by applying force on the pedal. So, what you did in these two examples, you changed the point of application of the force and you applied force at a convenient point to make your task easier. Another and the last function of a machine is to change the direction of effort to a convenient direction. And the best example for this one is a pulley. A single fixed pulley, if you have observed, the effort and the load both are equal. That means you do not gain in advantage, you do not gain any mechanical advantage. That means you cannot use a single fixed pulley as a force multiplier. If you have to lift a load of 100 Newton, then the force which is applied is definitely minimum 100 Newton. But still it is convenient for us to use because you have changed the direction of effort to a convenient direction, which is towards gravity. So, here instead of being effort equal to load, the direction of effort is towards the direction of gravity and hence it is helpful. Similarly, in a claw hammer, the claw of the hammer pulls up on the nail. The hammer changes the direction of effort or the force applied to a convenient direction. So, these are the four major functions of a machine. So, in today's period, you learnt about, you revised few technical terms related to the functions of related to a machine, as well as you were taught the major functions of simple machine.